Well, my take is that we're going to end up with flash and trash. And what I mean by that, you're going to end up with extremely high capacity, very slow spin speed, low performance disks for long tail storage, and pretty much everything else. All the day-to-day stuff is going to be stored in solid state. We're going to be seeing much more of a solid state data center, much less of spinning disks. I think we'll find that for some data centers it will be all flash, and that the long tail stuff will be pushed out to the cloud. So I think there'll be a fundamental difference. It also means that new solid state technologies, as they turn up, things like phase change and so on, we'll see those slotting in. We might also see, because as we're moving towards solid state, we might also see the way that we get this data fundamentally changing. Right now, we get data from solid state disks, SSDs, we treat them like disks. Why would we do that? Why would we want to get a block of data from a piece of memory? Why can't we just address it directly using the address bus and the data bus on the microprocessor? So I think we're going to see different processor architectures that allow us to deal with solid state memory, and perhaps up petabytes rather than gigabytes of solid state memory, which means that you've got massive addressable space, and things like SAP HANA, which is an in-memory database, actually really making use of DRAM and solid state at the same time. So I think there's going to be a change in interfacing, a change in processor design. It's really obvious. Why are we hanging on to the spinning disk form factor and the SAS interfaces and SATA interfaces that came from decades ago, when in fact this technology could be better and more efficiently used directly? Well, some people would say that tape has no future at all. I challenge that. I think that tape is a very important technology. Every time that you store data, you need to maintain electricity to keep the disk spinning. And if you're going to keep that for a long time, it's going to cost you a lot of money. If you put it on tape, the tape sits on the shelf. It doesn't cost you anything. So people would say tape's dead technology. Wrong. I think the dead technology, and this is actually coming out from the market as well, is the high performance magnetic disks. 15,000 RPM spinning disks, which use a lot of electricity. The way that, if you look at a disk, the diameter of the platter that you store the data on and the spin speed are both square laws in terms of how much energy you use. So basically, if you make the platter very wide, it doesn't, the amount of power you need to spin it at the same speed doesn't go up linearly, it goes up exponentially. If you spin it faster, if you spin it twice as fast, once again, the amount of energy you require doesn't go up linearly, it goes up exponentially. It's an upward curve. So what we're seeing is small 3.5-inch drives with slow spin speeds are very power efficient. Larger drives with very high spin speeds are very inefficient. So my take is that those are really dead, and flash memory is going to replace those really quickly.